Okay, guys, so we can't really start forensic chemistry without talking about blood. It seems like blood is going to be the most common thread that we need to start off with before we understand how a lot of these examples and lab experiments are going to work. So, this is going to be the first lecture module. We're going to learn about what blood is. Now, I know what you're probably saying. You're probably saying, well, I know what blood is. What else can be said about it? Well, you might not know what blood is, but do you really know what it is? That's kind of a weird question to ask, right? So all this time we know that if we cut ourselves and we bleed, we know what that red liquid is coming out of our wound. But do you really know what it's made up of? That's the question that we're going to have to ask, right? And we're going to have to answer that. And we're going to have to understand it. Because only when we start understanding that common thread will we be able to understand some of the testing and some of the reasons why we have to do the test the way that we do throughout the next couple of weeks in the semester. Okay, so here is the breakdown. When we start talking about blood, there's 4 major components. Up at the top, I've wrote this word fancy terms because that's what they are. They're fancy terms that people like to use sometimes, and I've just associated that with what maybe we have been acknowledged or acquainted with. The very first one are red blood cells. I'm going to abbreviate that as an RBC for red blood cell. Go figure. But if we talk about red blood cells, layman terms, we call them red blood cells. But if we wanted to sound smart, there is another term that can be used, and this term is called erythrocyte. So I could use red blood cell or I could use the word erythrocyte, but I want you to understand that whichever term gets used, they were referring to the same thing. And these are the most abundant type of cells. They contain a protein. This word protein we're going to have to look more closely at sooner or later. And that protein is going to be called hemoglobin. And hemoglobin swims around in you at all times. And the purpose of the hemoglobin is to carry oxygen, O2. It carries it out to your extremities, if you want to think of it that way, your fingers and your toes. And the red blood cells are produced in the bone marrow. All right, so now we know the purpose of red blood cell. Red blood cells have a purpose. That purpose, part of it, is to carry hemoglobin, which carries oxygen to the sites that need it. All right, so part number 2 is going to be called a white blood cell, and I'm going to abbreviate that as WBC. Keeping it easy for you. And if I don't want to use the term white blood cell, I'm going to use the term leukocyte. Again, either one of those refers to the same thing. One's fancy, one's layman term. All right, so the purpose of the white blood cells, of course, it's part of the immune system. The white blood cell will actually go out and it will target these viruses that we might get that start to get carried around in our body, and it sees that as an invader. And the white blood cells will go out and they will attack those invaders and they will kill it. Those invaders, things that are there that are not supposed to be there, your body's very particular. And these soldiers that we call the white blood cells will go out and it will kill those pathogens. And that's the term that we use. Pathogens are things that are not supposed to be in your body. Your body knows what's supposed to be there and what not supposed to be there. And if it red flags something that says a stranger in the house, the white blood cells will go out, attack it, and hopefully kill it. All right, so red blood cell, erythrocyte, white blood cells, leukocyte, and pathogens are bad things. All right, part number 3 is going to be called plasma. Now, plasma is going to be part of your blood. Whole blood is what we call that. If you cut yourself, you are leaking whole blood. And part of that sample is going to be the plasma. The plasma, if we just look at plasma only, it's very yellowish. So it has an associated color. And that yellowish layer to the blood has all of the other mixtures of the soup. And I've listed some of those here on the screen for you. Some of those are electrolytes, which make our body function, nutrients and vitamins, which we need for various purposes, maybe various hormones, if you're hormonal, probably, clotting factors. So if we do cut ourselves, how do we stop bleeding? Those clotting factors are going to be present in plasma. And other proteins, again, like antibodies to fight infection. All right, so we're going to talk a little bit more about antibodies a little bit later on. But it looks like the plasma, if this was alphabet soup, is the majority of the soup, right? A lot of good nutrients and vitamins and everything that we need is part of the plasma. And then finally down here at number 4, we see this platelet term. And we call those thrombocytes. These are the specific clotting factors that are carried in the plasma. They coagulate. They clump together. And it basically seals a wound, not steals a wound like you're seeing here on the screen. That should be seal a wound and prevent the loss of blood. So I want to go back to number 3 here because I skipped over something on purpose. It looks like plasma is everything that's down below, right? And then it looks like at number 4, we kind of took these clotting factors and we've identified these clotting factors with a different name. We called them platelets or thrombocytes. Under the umbrella of plasma, what they do is something funny, and they sometimes look at these clotting factors and they will remove the clotting factors from plasma. And if we do that, we do not call that plasma anymore. We now call that serum. And that's what you're seeing here. Serum's different. Serum contains no clotting factors at all. So whole blood, like whole milk, includes everything. Whole blood are the red blood cells, the white blood cells, the plasma. And that plasma contains everything. Electrolytes, nutrients, vitamins, hormones, clotting factors, proteins, antibodies, you name it, it's there. But depending on the forensic test that we're going to be doing, sometimes whole blood is okay, and sometimes it's not. Sometimes what has to happen is that I have to take a blood sample and I have to spin it down in a centrifuge. And when I spin this blood sample down in the centrifuge, blood will separate. And what I'm going to get down here at the very bottom is kind of that red blood stuff that we would characterize as blood. But when we spin it down, we're separating these two liquids from each other. They are immiscible. They don't dissolve quite well, and we can separate them out through a centrifuge. And what we're seeing up here at the top, this yellowish piece, that is the plasma that's associated with that person's blood sample. And sometimes plasma is okay to test. We don't need all the other stuff. We just need to look at the plasma layer. Sometimes the whole blood sample is okay to test. That really just depends on the test that's given to us that we have to perform. Now, if I go back and take a look at plasma, it looks like there's two different versions somewhat of plasma. This yellowish portion that includes the clotting factor, or if it doesn't include the clotting factor, we're going to call it serum. And the reason that we are picking that out is because sometimes in these tests, just straight plasma is not going to be good. Those clotting factors are going to cause us some interferences. So we would like to sometimes remove those clotting factors so they don't cause us a problem in the test. And if we remove those clotting factors, we don't really call it plasma anymore. We call it serum. This is a person's blood serum or blood plasma. And that's the differences between those two terminologies. Okay? So how do we do it? I said we centrifuge it down. Well, this is typically what goes on. So what would happen is that if I had a suspect or if I had a patient that would come in, I would draw a blood sample from them. A lot of times this is done by someone that is trained in this process, like a phlebotomist, and then they will extract a whole blood sample from that person. You might have had this done before when you'd go to the doctor or a clinic and they do a random blood panel on you. All right, so they take this blood and they put it in some type of tube. Here they've drawn it as a test tube, but it doesn't really a test tube, but it's somewhat of a conical tube with a lid at least. And they can centrifuge this stuff down. And when they centrifuge it down, then they can separate the two layers. Plasma is normally on top, and then this other crap that's inside of your blood will settle down here to the bottom. But if they don't want to centrifuge it, they could add sodium citrate and allow this blood sample to stand. They do not put it in a centrifuge maybe after that. And if you add sodium citrate, then it kind of does the same thing. It really just depends on the process that you want to use in a laboratory. All right, so down here below is the sodium citrate compound. We see the sodium piece here in front, and then this huge thing here is called the citrate piece. Well, I see a lot of OH groups. I see a lot of free pairs of electrons on this molecule. So that means that this molecule is probably polar. And that polarity is very good because that polarity, because we're aqueous beings, we love water, can actually dissolve in this blood sample and do what it needs to do. And it salts out. That's what we call it. It salts out the plasma from the rest of the blood sample. This rest of the blood sample that we're talking about, these are mainly erythrocytes down here at the bottom. These erythrocytes are about half of whole blood. Here they've stamped 45%. If I go back to this picture and we look at erythrocytes, we're talking about red blood cells. That is half of a person's blood sample. About it, give or take a little bit. That's also why in this picture you see the majority of that red. The majority of that is going to be your red blood cell. All right, so if I go back to this diagram, it looks like there's kind of a layer in between here. In between the plasma and in between the red blood cells, there's this thing called a buffy coat. Doesn't that sound all nice, warm, and inviting? I want to wear my buffy coat for winter. That buffy coat represents the leukocytes and the platelets. So if I go back to this diagram that we started off with, the leukocytes are the white blood cells, and the platelets are the clotting factors that are carried in plasma. So again, I have the opportunity to separate those out if I want to. Less than 1% of whole blood represents those two pieces. So they're not there in a very large amount. And that buffy coat can also be seen in this picture. And you kind of see it right there. It's not truly yellow. It's beigey. That's definitely not red. That could probably be spun down a little bit more and separated a little bit better to get some more of the red out. But as soon as you pick up these tubes, they're going to start mixing a little bit. And that's why you're seeing that into the picture. So that gives you an idea of how blood is basically processed in a laboratory. And depending on the types of tests, again, that's going to determine if a person's whole blood sample is going to be tested or if only a certain part of the blood sample is going to be tested. All right. So let's talk about some blood facts before we go on. Blood facts. Number 1. You, as a person, you have about 5 liters of blood, which makes up about 8% of your body weight. So think about that. If you are a male that weighs about 180 pounds, almost 15 pounds of your weight will be blood. So if someone cut you, and if someone drained you out, and then re-weighed you after you have no blood in your body, you will weigh about 15 pounds less. That's quite a bit, right? When you look at it that way as far as poundage goes, 7 to 8% of your body weight is nothing but liquid blood. And we do classify blood as a living tissue. It's kind of weird, right? Tissue, we normally think of skin, something physical that we can touch, that's solid, membraney kind of thing. But we do classify blood as a living tissue. And the purpose of blood is to carry all the things that your body needs. We've already mentioned oxygen, but it also carries various nutrients to where they need to end up going. So you need to think of this as almost like a freeway. And the cars on the freeway are the things that your body needs in order for it to work. And that blood is the freeway to allow the travel of all of these things that your body needs. And it takes it to where it needs to go. Some of the other things that we don't quite talk about often, but it is a purpose of blood, is it carries other waste products. So not only the good things to where they need to go, but as your body is creating waste, in whatever form that might be in, the blood is also the freeway for those. And it helps your body to basically get rid of the waste products. So very often you are taking these waste products to your kidneys or maybe to your liver. And your kidneys and your liver are disposing of it from that point and getting it out of your system. All of that could not happen without the activity of a blood and a blood cell and your whole blood sample and that 7 to 8% of your body weight. Now let's go a little bit smaller. One drop of blood cell, maybe 2 or 3. You're looking at 1 billion red blood cells. Huge, right? When you think about it that way, 1 billion, most of us can't even comprehend that amount of money, much less that amount of red blood cells. And that many is just in a couple of drops of blood. And we can do so much with just a couple of drops of blood that it's almost unrealistic. But that's all that we need. And that's what you're basically going to do in our first lab when you get to that point. For every 600 red blood cells, we're going to equate that to about 40 platelets and 1 white blood cell. And keep in mind, the white blood cells target infections. The white blood cells target the pathogens that might be present. And that 1 little white blood cell for every 600 red blood cells are going to protect your body and protect you from disease and decay and possibly death. So now we're starting to comprehend a little bit more about what blood is. We all have it. We've all cut ourselves. We've all seen it. And now we're starting to break that definition up and get a little bit more scientific in what is actually present and what it actually does. So that's where I'm going to stop this first video. In the next video, we're going to continue our discussion of red blood and the things that I can do with it and the things that we need to kind of focus on before we get this semester truly started.